All right, so the final method that we're going to talk about for solving systems of equations is solving them by addition. You your textbook doesn't call it this, but some textbooks call it the elimination method. So before I show you how to do it, let me just tell you that solving a system by addition is either going to be the fastest possible way that you can solve the problem, or it is going to be a nightmarish hellscape from which there is no escape. So when you are doing these problems, you need to spend some time looking at it first to make sure addition's the smartest way to do this. Because if addition's the smart way to do it, it's really smart. And if it's not the smart way to do it, it's super dumb. So how can you tell just by looking at a set of equations whether or not addition is a smart way to do it? Do you have two variables that are exactly the same except one's positive and one's negative? And in this one, yes we do, positive y and negative y. Now the reason why this is called the addition method is because the way that you do this problem is you stack the equations one on top of the other, just like this. The x's are stacked, y's are stacked. This is important. The equal signs are in the same spot, and the numbers are in the same spot, and literally you add them straight down. X plus x is 2x. Y plus negative y is 0, so the y's are gone, and 7 plus 5 is 12. This is why it's sometimes called the elimination method, because the y's have been eliminated. This was the same goal that we had when we did substitution. The goal was, can we write an equation that only has one variable in it? And now we've done it. This equation only has one variable, it's x. Now we're just going to solve for x, which is a one-step algebra problem. X equals 6. How do we find y then? Well, we're going to do substitution. I can substitute x into either one of these. It doesn't matter. I'm going to substitute it into the top one just because it's plus instead of minus. So I'm going to have, instead of x plus y, 6 plus y equals 7. And again, this is a one-step problem. I'm going to subtract 6 on both sides. Y equals 1. So my solution is 6, 1. So you can see how fast that was. It's super, super quick. Barely any work at all to do addition. Now, the one that I just gave you was an example of one where it's pretty obvious we should solve this by doing addition. Let me give you one that's less obvious. Okay, so this one's a little less obvious that we're going to solve this using elimination because unlike the last one, we don't have two variables, one on top of the other, that are exactly the same.
3y and a y?
Yeah, those are the same variables, but one's a 3y and one's just a y. And also the other problem is one's positive and one's negative, and I want one of each. I want a positive negative. I don't want two positives. But if that y was a negative 3y, that'd be good, right? Then the y's would eliminate when I added them. Is there something I can do to turn that y into a negative 3? And the answer is yep. What if I multiply this entire equation by negative 3? Well, I'd have negative 2x times negative 3, which is 6x. Positive y times negative 3 would be negative 3y. y. And then 2 times negative 3 is negative 6.
Why are you doing y?
Because by multiplying by negative 3, here's the bottom equation, unchanged. Now do I have variables, one on top of the other, except one's positive, one's negative?
Nope.
The y's, negative 3y over positive 3y. So now if I were to add these, the y's would go away. 6x plus negative x is 5x. Negative 3y plus 3y is gone. And negative 6 plus negative 4 is negative 10. Divide both sides by 5. X equals 2.
Negative.
Nope.
Yep, you're right, sorry. Okay.
All right, so say if it has a number which anytime it's just y's or just x's. So always want to do y's.
No, I want to do whichever one's going to be the easiest. In this case, I could have if I multiplied the bottom one by a negative 2, I multiplied this bottom equation by negative 2 instead. I would have had a negative 2x on the top and a positive 2x on the bottom, and that would have been okay.
Oh, okay.
I just did negative 3 because one of you said it. You're like, oh, what about the y's? That was.
You just pick one from the equation.
Yeah, it doesn't matter. I'm gonna do the bottom one just because it looks a little simpler. So it's gonna be negative x. So negative 2 plus 3y equals negative 4. Tiny little bit of algebra here, not that big a deal. Negative 2 is 2. All right, subtract 2 on both sides. I get 3y equals negative 6. And then divide both sides by 3. They're both negative 2. It's an amazing coincidence. Negative 2 is the solution. Oh, that's Earl. Don't mind him. He's fine. Don't bother the mosquito. Mosquitoes are more afraid of you than you are of them. I made that up. That's almost definitely not true. That is a lie. I apologize. Please do not pet the mosquito. I take it then that you really love spiders?
Yes.
Because spiders will eat mosquitoes?
Really?
Yeah, or bats. You should put a bat house in your backyard. It'll eat. Cats eat mosquitoes?
My cat does. My cat eats anything that flies in the house.
Your cat has problems. You can get a bat house. You can go buy them for $20. Put a bat house in your backyard. Bats will nest there, and at night they'll come out and eat all your mosquitoes. So you'll have no mosquitoes, but probably rabies. But it seems like a fair trade. So take a look at this set of equations here. Nothing that is really obvious that eliminates. Is there any way I could multiply either the top equation or the bottom equation to get stuff that looks the same? Now, my instinct is the top equation because the numbers are smaller. So what could I multiply the top equation by that would help me do some elimination? Yeah, if I multiply the top by -4, that seems like a good idea. So that's going to give me -8x plus 4y equals -28 on the top. And on the bottom, I didn't change anything. It is possible to multiply the top and the bottom by different numbers to make them the same, but at that point, it sometimes ends up being more work than it's worth. You just do substitution. Okay, let's go ahead and add them. So -8 plus 8 is 0. 4 minus 4 is 0. So on the left side, everything's gone. And on the right side, -28 plus 1 is -27. Who's got a theory?
Undefined or infinity.
No solution.
Why would you say no solution?
Infinity.
They don't equal each other.
Very good, because the variables went away, and what I was left with is a statement that is false. 0 doesn't equal -27. This is what no solutions looks like. The variables drop out, and what you're left with is a false statement. No solutions.
You don't even have to go that far.
Yep, that one's not bad. I like those. That's a good guess. Nothing real obvious there. You see any multiplication we could do that would help us out?
The -6 and -3 or +6
Sure, what could I multiply by to make those the same?
to 6. A 3 would be easy, right? -3.
How could I turn the -3 into a -6 so that these would eliminate?
Times it by 2.
Yeah, let's times the top by 2.
Oh, because 6 and 6 plus 3.
So 8x minus 6y equals 10. And on the bottom, -8x plus 6y equals -10. Excuse me. Whoa.
0.
Mm-hmm. When I add these, over on the left side, the x's and the y's are gone. Over on the right side, 10 minus 10 is 0. All the variables are gone, so it's either going to be infinite solutions or no solutions. It's no solutions? Why infinite? Yeah, because 0 actually does equal 0, kids. If you end up with a true statement, it's infinite solutions. It's hard for me to think of an example of addition where you end up with something besides 0 equals 0 and it's infinite solutions. Like, I can't think of a time when you come up with like 7 equals 7. Because if you've done it right, the x's and y's will completely eliminate and you'll have 0. So 0 equals 0. I can't think of a time when it wouldn't be that. You're going to buy a lottery ticket? Because 0 equals 0? I mean, you could have bought a lottery ticket any day if that was your threshold. So, just for the sake of completeness, I want to show you an example where you technically can do addition, but it's not like the best idea anybody's ever had. I'm going to show you how to solve this one using the addition method. And hopefully when we're done doing this, you are going to have a newfound appreciation for when you should not use addition, when you should use the substitution or graphing methods instead. And here's why. There is nothing I can multiply the top by that will eliminate any variables. There's nothing you can multiply 3 by that's going to give you -5. There's nothing you can multiply 4 by that's going to give you +9. Unless you start thinking about multiplying by fractions or decimals, which sounds like the worst idea. So this is an example where we have to multiply the top and the bottom by something. The top and the bottom. For example, if I was looking at eliminating, let's say, the y's, just because. The reason I say y's is because one's already positive and one's already negative. I just need them to be the same number. What's a common multiple of 4 and 9? Huh? 9 can't be divided by, or 24 can't be divided by 9.
Oh, no.
36 can though. So if I could turn those both into 36s if I multiplied the entire top by 9 and then multiplied the entire bottom by 4. So the top is going to be 27x plus 36y equals 9 times 13 is 117. And then on the bottom, 4 times 5 is 20. Negative 9 times 4 is negative 36. And 6 times 4 is 24. That took a little more work than I really wanted to do, but I can eliminate some stuff now. So 27 plus 20 is 47. The y's are gone. And 117 plus 24 is going to be 141. Divide by 47. It looks like it's going to be nasty, but actually, pretty sure 141 can divide nicely by 47. I think it's 3. Somebody check me. I'm pretty sure it's 3. Good. I mean, I knew that, obviously.
Sure.
So now that I know that x is 3, I can plug it into either one of these. I think the top one's probably a little easier, don't you? Just because the top one has smaller numbers. So 3 times x, which is 3, plus 4y equals 13. And now we'll do a little bit of algebra. 3 times 3. Subtract 9 on both sides. So 4y equals 4. Divide by 4, and we get y equals 1. So the actual solution is 3. So that is a time when perhaps using the elimination method is not the best idea anybody's ever had.
So whenever you can't multiply anything by a variable like that, like the other ones. Yeah.
Right. If it requires multiplying twice, you can still do it, obviously. We just did that one. And I mean, some of you may be looking at that thinking that wasn't too bad compared to substitution. Like it was less algebra than substitution would have been. If you want to do it this way, you can. There's nothing wrong with it. But you do have to do a lot of multiplication. You have to be able to see what you have to multiply the top and bottom by.
You got 2 extra lines.
Stay in school. My mom told me to get a real job, but I wouldn't listen. No, Mom, teaching is where I'm needed.
Hey, at least you're here for the party.
Should have listened. Like, son, are you sure you wouldn't rather do something where you get to deal with little better people, like a parole officer? I was like, no, Mom, no. Teaching is where I'm needed. Oops. I don't think I made my Alfred Hitchcock quite big enough there. Okay, so I'm with you. I don't feel good about all these fractions.
I'll put next.
Yeah.
I'll put 0.
I don't feel great about the fractions. But
Is it y over 2?
it's y over 2. Something that we have learned prior to this class is how to get rid of fractions if you really don't want to deal with them. And now it makes a lot of sense to use that method because it's how you do elimination in the first place, which is to multiply through by something. So look just at the top equation. Is there something I could multiply by that would just get rid of the fractions? Yeah, 2. If I multiplied everything up here by 2, what would I be left with? Well, that'd be negative 2x minus, what's y over 2 times 2? 1y, equals, what's 5 over 2 times 2? 3. 5. Good.
So that's, yeah, 5 times 2 divided by 2, right?
Yes. What could I multiply the bottom by? Would 2 work?
3 can.
I don't think 2 or 3 would work because it won't get rid of the 6. I got to multiply by at least 6 to get rid of it. Because x over 6 times 6 is 1x. Minus, now this would be 6y over 2, which reduces to 3y. And then 0 times 6, which is 0. So I've solved your major problem you had, which is I don't like the fractions. Unfortunately, I can't eliminate anything right now. There's no addition to do. So let's multiply again. Could I do another multiplication that would help me eliminate something? What is it? Multiply the top by 3? You're close. It's got to be a negative 3 because I need this negative y to turn into a positive 3y. So I'm going to leave the bottom alone, and the top is going to get multiplied by negative 3. So that's going to give me positive 6x plus 3y equals negative 15. And the bottom's going to stay the same. X minus 3y equals 0. Okay. Now what? Let's add. Good plan. 6x plus x is 7x. The y's are gone. And negative 15 plus 0 is negative 15. Well, this is kind of a good news, bad news situation here. It's going to be a fraction. I'm about to have x. It's negative 15 sevenths. So the good news is I got x. The bad news is it's beautiful on the inside. I got to find y. So I can go back up and plug it into either one of these equations. Unfortunately, plugging it into either one of those equations means I'm going to have to deal with fractions again. So I'm not going to plug it into either one of these. I'm going to plug it into one of these. I'm going to plug it into one of the ones after I got rid of the fractions. Now looking at these two, which one's going to be the easiest to plug in x? Top or bottom? You think the bottom one? Okay. So I'm going to replace the x with negative 15 sevenths minus 3y equals 0. That doesn't get me super excited to get out of bed in the morning, but I think we can make it work. Let's get rid of the fractions. What can I multiply by that'll get rid of this fraction?
3.
I got to multiply by at least the denominator, so at least 7. That'll give me negative 15 minus 21y equals 0. Negative 15 sevenths times 7. If you do negative 15 times 7 divided by 7, it's like the 7s cancel out. 3 times 7. Well, it's already negative 15, so let's add 15. That gives me negative 21y equals 15. Then what?
Plus 21.
I don't love that. Divide by negative 21. So y equals negative 15 21sts. But I feel like 15 21sts can reduce.
3.
They can both be divided by 3. So negative 5/7 is going to be my y. So my answer is negative 15/7, negative 5/7. Yeah, that's a doozy. That is a doozy.
Yeah, what's the next?
That's one where you start figuring out, like, if I just skip this one, could I still pass? They're not that bad. You can handle it. I got faith in you. Does anybody have any questions?
It ain't gonna get harder than that.
It's not going to get harder